The paper presents a novel approach to short-term relocalization in monocular keyframe visual SLAM (MKVSLAM) systems by introducing a multimodal keyframe descriptor that incorporates semantic information of objects and spatial information of the camera. This descriptor is integrated into a keyframe-based place recognition (KPR) method, which is formulated as a multi-stage keyframe filtering algorithm. The proposed approach leverages advancements in semantic data extraction using deep neural networks and presents a fast and accurate solution to the short-term relocalization problem. The KPR method is coupled with an off-the-shelf 3D/2D pose estimation technique to create a novel relocalization pipeline. The paper also discusses the integration of the proposed KPR method for improving short-term relocalization within the ORBSLAM3 MKVSLAM framework. The contributions include the development of a new keyframe descriptor called the Pose Semantic Descriptor (PSD), and the formulation of a novel KPR algorithm called the Pose Class Box (PCB). Here is the combined summary of the 4 pages. The proposed short-term relocalization method, implemented as Algorithm 1, combines Pose Box Constraints (PCB) and Class Box Constraints (CB) methods to select keyframe candidates from the pose graph in the active map M. The PCB method is used when the Euclidean distance of the keyframe from the origin is greater than a threshold, while the CB method is used otherwise. The algorithm iterates through the keyframes, computing the PSD descriptor and performing relocalization using the selected method. If the tracking state is not resumed within a predefined number of time steps, a new local map is initialized. The system is implemented in Robot Operating System (ROS) on a computer with Ubuntu 22.04, Intel i5-9300H at 2.4 GHz, NVIDIA RTX 2060 GPU, and 16 GB RAM, incorporating the PSD keyframe descriptor and PCB KPR method in ORBSLAM3, and the object detection module uses YOLOV5L. The experiment is performed on 18 indoor image sequences spanning across 4 unique datasets, including Euroke MAV, FR2 Pioneer SLAM, and LSUI Core Mono datasets. The proposed relocalization method is tested in all 18 image sequences, and the results are compared to the DBOW2-based relocalization method in ORBSLAM3. The metrics used to evaluate the performance of the system include the mean average precision (MAP) metric for object detection, average execution time, and average keyframe candidates selected for the KPR method, and the average total execution time, average number of frames spent in lost state, and average number of local maps created for the relocalization method. The results show that the proposed KPR method is faster than the DBOW2 method, with an average execution time of 0.297 milliseconds, and selects more keyframe candidates. The proposed relocalization method performs better than the DBOW2 approach, reducing the time spent in the lost state by approximately 50% and creating fewer local maps. The absolute trajectory error, 8, score is also lower for the proposed approach, indicating higher positional accuracy. The paper proposes a new multimodal keyframe descriptor based on semantic information of objects detected in the scene and camera poses calculated from monocular images, and develops a novel KPR method to select appropriate keyframe candidates from the pose graph using a 3-stage filtering algorithm. Future work will integrate 3D object pose and information theory to expand the method into a multi-agent framework.